Hi everyone, in this video we're going to continue our discussion of matrices and building up to the idea of being able to invert a matrix. In order to get there though, we need to discuss one more thing, and that's matrix determinants. So a determinant is a very important value when dealing with a matrix. It's going to tell us a lot of information about the matrix itself, and we'll talk about that in a little bit. But most importantly, we use a determinant to invert a matrix. And remember that inverting a matrix is necessary when we're calculating coefficients for the ordinary least squares or OLS model in econometrics. In fact, we use matrices a lot in econometrics. That's why I keep coming back there. Anyways, we can analyze the inverse of a matrix, but in order to do so, we need this technique. We need the determinant. So this lesson is designed to familiarize you with calculating the determinants of a 2x2 and a 3x3 matrix. Now, this is not a general technique for calculating a determinant. If you want to learn that, you're going to need to take a more formal linear algebra course because it's much more complicated than that. What I will tell you though, and this is a bit of a disclaimer, these tricks that I'm going to teach you will not work on anything larger than a 3x3 matrix. So don't try to apply them to a 4x4. You will not get the correct answer. Anyways, let's jump right in. So let's suppose we have the following 2x2 matrix right here. And I'm using letters here because these are all going to rely on formulas. So I have matrix A of A, B, D, and E. Well, alright, if I want to calculate the determinant of this, I just take the main diagonal, which I call the positive diagonal, A and E, multiply them together, so A times E, and I subtract the negative diagonal, starting from the top right and going to the bottom left, or B times D. And that's it. That's all we have to do to calculate the determinant of a 2x2 matrix. AE minus B times D. And yeah, there's nothing more to it than that. The positive diagonal minus the negative diagonal. So that's all there is to it, but let's do a 3x3 matrix because this is a bit more complicated as well. So anyways, here's our 3x3 matrix right in here, matrix B, and that's A, B, C, D, E, F, and G, H, I. And again, it's going to have a formula. It's going to rely on positive and negative diagonals, but it's a bit more complicated this time. So the determinant for matrix B is going to be A times E times I plus B times F times G plus C times D times H minus A times F times H minus B times D times I minus C times E times G. So you might be wondering how on earth you're going to memorize this formula, but I'm telling you, you don't really even need to memorize this because all 6 of these terms are the 6 different diagonals in this 3x3 matrix. So that first one, A times E times I, that's the main diagonal right there, going from the top left to the bottom right. B times F times G, that's the second diagonal. We start at B, go down and right to F, and then we wrap around and come back to G. Same thing for the third one. We start at C, wrap around to get to D, and then we go down to the right to get H. So those are our 3 positive diagonals in this matrix, and we add them together. And then we subtract our 3 negative diagonals. So I start with A, wrap around, get F, and then continue moving down and to the left to get H. Then I subtract B, move down and left to get D, and then wrap around to get I. And then lastly, I do the final negative diagonal, C, down to the left to E, down to the left to G. And that's all there is to it. Take the 3 positive diagonals, add them together, take the 3 negative diagonals, and subtract them. And that gives you the determinant for a 3x3 matrix. So yeah, it's a very straightforward trick. But again, this will not work on anything larger than a 3x3 matrix. And if you want to learn how to do things for like a 4x4 or 5x5 matrix, you're going to need to take a more formalized linear algebra course. All right. So the value of this determinant, though, it tells us some very interesting properties about a matrix. Specifically, if the determinant is equal to 0, it means that our matrix is singular. And that kind of a matrix can't be inverted. And that's going to be important as we try to invert matrices later on. But any type of non-zero determinant, any type of matrix with non-zero determinant can be inverted as normal. So it's really useful when you're calculating the inverse of a matrix to calculate the determinant first. Because if you get a value of equal to 0, you know that you can stop right there because you have a singular matrix and there you cannot actually invert it. So anyways, that's all for this video. Thanks for watching.